This video is going to cover my invention, the two-point rule for determining how to create the correct shape of curvature on a shear and moment diagram. So it's pretty simple, and if you don't know anything about shear and moment diagrams, go take a good look at the shear moment diagrams video for graphical methods that's coming up, and that will help you see what we're talking about. But basically, we're going to go for the shear moment diagrams. We go from load to shear to moment. And usually it's when you're going to the moment diagram that things starts getting tricky because you have a certain load that's creating a shear, and your shears of a certain shape, and that's the easy part. But then for the moment it gets a little bit weird. And so to make sure that you're drawing the curve in the right direction, I've created this wonderful two-point rule. And basically it boils down to, if a shear is positive, then your moment goes up. That's pretty basic. What that does mean though is that the first point, because again this is a two-point rule, that your first point is lower than your second. Right? Because if moment's going up, that means for moment, our first point on the graph is lower than our second point. So this is our first, and this is our second. And obviously, in order to go up, the second one has to be higher than the first. So however you really want to say it, that's really what's going down. And second, if shear is negative, then the moment, I'll just say M, goes down. Again, it's the exact opposite, right? That does mean that the first point is higher than the second. So again, if we were to kind of draw that out, we have M. This means that our first point is up here. That's number one. And point number two is down here. So our first point is higher, and that gives us a, downward sloping type thing in some way or shape or form. So, but the real question with these is not necessarily does it mean that moment goes up or moment goes down. The question is, which direction is the slope, right? Because you have two options here effectively. You have the one where we are concave, and you have the one where we are convex. So the question is, which one of these is the correct one? That's the question. And how do you know? Well, that's what we're going to do in our next step here. Our next step, what we want to do is we want to look at the shape. So look at the shape for your shear, obviously. Look at your shape for the shear and ask yourself, which side is bigger? Which side is bigger? That's the big question here. Which one is bigger? The left or the right? The bigger side is going to have a bigger slope. Now, what does bigger slope mean? Let's think about the slope of a line. If you have a really big slope for a line, what does that line look like? Pretty much vertical, right? So you can draw like a vertical line. I'll show you what that means. And on the smaller side, we're going to have the smaller slope. So what's a really small slope of a line look like? Pretty horizontal. Not entirely horizontal, not entirely vertical, obviously, but something along those lines. Once you've effectively attached the slope to the side, the left or the right side, then all that's left to do is to follow the slopes. Follow the direction that the slopes are telling you to go to connect the points. That's literally it. That's the two-point rule. So again, this is usually for determining what direction, concave, convex, is our second degree and also third degree slope. So let's do some examples, because who doesn't like examples? So we're going to have a shear, and on our shear we have positive, negative, and we're going to have a slope, right? We have a slope. We're going to make sure that shear is a 1 degree. That means that the moment is going to be a 2 degree, right? Because it's 1 more degree than the shear. And the question is, what does the moment diagram look like? So let's start. Step number 1. Is shear positive or negative? Shear is positive. So that means moment's going up. So point 1, this is our first point. And point 2 has to be higher than point 1. So point 2 is up here. This is our second. Now, look at the shape. You're seeing the triangle. Which side is bigger or which side is smaller? Really look at the size. So I'm going to go left to right, actually. I'm looking at this side versus I'm looking at this side. Which one of those two is bigger? The green one's bigger, so the green one, that's going to be, the second point is going to be very vertical, so I'm going to just kind of sketch in a vertical line there. And the red side, the first side, is going to be very small, so he's going to be kind of horizontal here. And all we need to do now is connect the dots. Let's do it in blue. So I'm going to follow this out. I'm going to follow this out, and I'm going to get that shape. So I'm going to get my curve looking like this for my moment diagram. Obviously, maybe it doesn't look like that. The point is that it's the one where it's kind of sloping on the underside, you know, be it like this, be it like, you know, a little bit less. However it really is, this is why we label our graphs. So again, this is a 2 degree. Okay, so let's do it. We're going to do it 3 more times. We're actually going to see every single possible combination of this if we do it this way, but I'm going to switch it up here right now. Now we're going to do our shear is going to be a 2 degree. So it's going to look like this. How do you get a 2 degree shear? Well, when you have a 1 degree load. How do you have a 1 degree load? That's called a linearly distributed load. So can you see those? Absolutely. And then what's our moment going to be? Moment's going to be 3 degree. And you might be freaking out thinking, I don't know what the hell the shape is of a 3rd degree slope. It looks just like the 2 degree, honey. Yep, it's just a little bit more severe. That's literally the only difference between them, but it's going to function the exact same. So again, shear is positive, which means moment's going to go up, which means first point's down here and second point is up here. Okay, that starts off the same. Let's look who's bigger. What's going on over here? Well, on our left side, it's really big. So on our left point here, we're going to have really big. So that's pretty vertical. On our right side, that's the smaller side. So therefore on the right, which is our second point, it's going to be smaller. Connect the dots and we're going to be coming out pretty vertical, finishing pretty flat, and you betcha you're going to go like this. Again, that's a 3rd degree slope. Connect the dots. Connect the dots. Just kind of follow them out. There you go. There's the slope. We do it again. You said, oh, we've only done positive things. Sure, let's do shear in the negative. Let's do, we'll do this one. We'll start off with a really big negative. But we're going to do a 2 degree slope again, because why not? Those ones magically seem more difficult, right? Even though they're really not, they're the exact same. So if shear is a 2 degree, moment's going to be a 3 degree. This time it's negative, which means that the first point is higher than the second point. Okay, so the first point is higher than the second point because we're going to be going down as we go left to right. And looking at this, I'm seeing that we'll go over here on the right. We're already in green. Over here on the right, that's pretty small. That's pretty flat. Over here on the left, that's pretty huge. That's pretty huge there. Connect the dots. Coming down pretty vertically, ending pretty flat. Ta-da, there is our 3rd degree slope. We'll do it one more time for our last scenario. You might be thinking there's plenty of other scenarios. No, technically not. I could have just drawn triangles instead of 2 degree slopes. It's all the same. It's literally all the same. So here's our fourth one that we have. Positive, negative. Technically, the only other one that we have is it's increasing, going down as a 1 degree, right? We have where we started off small, but we went up. We have where we started off big and we went down, but they were both positive. Now we're doing the both negatives where we either start big and small or start small and big. Yep, so these are the only 4 options that you really have. So if shear is a 1 degree, moment is a 2 degree. Again, we're negative, which means moment's going to go down. So the first point for moment is a lot higher than the second point. That's what going down means. Over here on the left, we're small. So we're small. Over here on the right, we're really big. We're really big. Connect the dots following those slope suggestions. Maybe you got to do both at the same time. I like using my hands for this personally, not that you can see it. But I like using my hands, just kind of following, connecting my 2 hands together in an arcing motion. And there you go. This is supposed to be a 2. That's 2 degree. So you can see there are the 4 different scenarios that we have. Doesn't matter if it's 1 degree or 2 degree. It doesn't even matter if it's 3 degree or 4 degree. They're all the same. You're just going to kind of follow it. The only difference is that a 3 degree is a little bit more extreme than a 2 degree. But that's it. So hopefully using this 2-point rule, this can help you get the correct shape for your shear and moment diagrams, and that's not a concern coming up in these next videos.